Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about solving 2x2 systems. Now, hopefully this is a review from stuff that you remember from Algebra 1. So we're just going to be going through all of the different ways to solve 2x2 systems and changing up some of the terminology. So you're hopefully familiar with solving by graphing, which means that you graph and you see where your two lines intersect. And it's also known as an independent system. Independent meaning that there's one solution. So we call these systems consistent independent. Now, if you get coinciding lines, that means that when you graph, you get the same line twice. That's what's known as consistent dependent. And because everything matches up, your solution would be infinitely many solutions. Now, if you get parallel lines, they're never going to intersect. So there would be no solution there. And we call that an inconsistent system. Now, if you solve by graphing, you can take it, this is standard form. You can go from standard form and convert it. Some of you are familiar with graphing by intercepts, you can do that. But what I'm going to do is I'm going to put these in y equals mx plus b, or slope-intercept form. And then before I even graph, I should know, is it consistent, independent, consistent, dependent, inconsistent? And that's going to tell me what the graph will look like, and then therefore my solution. So if I solve this first one for y, I would subtract x on both sides. So I would get 2y equals negative x plus 7. And when you divide by 2, you would get y equals negative x divided by 2 becomes negative 1/2 of x plus 7/2. And then I'm going to do the same thing with my second one. So I would subtract 3x, so I would get negative 2y equals negative 3x plus 5. And then I would divide by a negative 2, so it's going to change my signs. So if I divide by negative 2, now I have positive 3/2 x minus 5/2. Okay, and as I can see, I have different slopes here, which means that my lines are going to intersect. They're not going to be coinciding. They're not going to be parallel. And that makes this system consistent independent. So I should have one solution here. Now, to go and graph these, I'm going to start with the y-intercept, which is at 7/2, which is 3.5. And it's okay that it's not a whole number. It just means I'm going to go between 3 and 4, so 3.5. And then if my slope is negative 1/2, I'm going to go down 1 over 2, and I'm going to stay between the points. So I would go down 1 and then over 2. Down 1 again and then over 2, and then down 1 again and over 2. And I want to do this a couple of times because I want really nice and neat, clean lines. And if you have on your ID, which you should, then what you can do is honestly just use your ID to get nice and neat straight lines. But I want to see the exact point where they're intersecting. So I want to have it be pretty accurate here. And now I'm going to graph that second one. So y equals 3/2 x minus 5. So minus 5 over 2. Negative 5 over 2 is negative 2.5. So this one's starting at negative 2.5. And now I'm going to rise 3 and then go over 2. And this is in the positive direction. So now I'm going to rise 3. So I'm going to go 3 between. And then I'm going to go over 2. And then I'm going to go up 3, over 2. And then if I have done it right, I should see where they intersect. And it's hopefully a clear point, which it looks like it is. So that point right there is our solution. So that point is 3, 2. But before you box it and say it's a solution, you might want to check it. A lot of this stuff in Algebra 2, you can plug your numbers back in and check it and then just know if you're right or if you're wrong. And if we're wrong, then we need to fix it. So going back to our original equation, I have the point 3, 2. So I'm going to replace the x with 3 and the y with 2. So what's 3 plus 2 times 2? 2 times 2 is 4. 3 plus 4 makes that 7. And then for the bottom one, so 3 times x is 3, minus 2 times y is 2. That's 9 minus 4, which is 5. It works. So my solution is 3, 2. Now let's take a look at another one. Now, you should see and notice that this is exactly the same and this is different. So that should be a clue as to what our solution is going to be and how the system is going to play out. But let's just say that you don't catch it. Let's just say you're on a roll. So if you were going to solve for y and put it in slope-intercept form, I would subtract the 2x. And then I would divide by 3. So I have 3y equals negative 2x plus 15, and then divide by 3. So I would get y equals negative 2/3 x plus 5. And now I'm going to do the same thing for the other one. So I would subtract 2x again. So I get 3y equals negative 2x minus 6. Divide by 3. And now I have y equals negative 2/3 x. And then negative 6 divided by 3 is positive 2. Or negative 2. I wrote it down wrong. Because negative 6 divided by positive 3. My bad. So negative 2. And now if you catch it, these have the same slope, but different y-intercepts. So if I come back up here, they're parallel lines. These are never going to intersect, which makes this an inconsistent system. So we don't have a solution. And if we were going to go to graph this, I have a y-intercept of 5, and my slope is negative 2/3, so down 2/3. It's going to look like this. And then the other one had a y-intercept of negative 2, and then it also had the same slope. So you're going to end up with these parallel lines that never intersect. Therefore, there's no solution. There's no values that would work for both of your equations. And that's essentially what a system is, trying to find the numbers that fit for both of your equations, the x and y that satisfy both of them. So no solution, nothing works. Now, this is solving by graphing, which is nice when you have an x and a y, or it's in slope-intercept form already, or you can kind of see it right here. What we're going to talk about next is solving by substitution. Now, substitution means to replace something. So how we do this is we solve one for a single variable, we substitute, we replace and solve, and then we're going to substitute and we're going to solve again. So when you're looking at your equations, solving for a single variable means you want to pick one and then get that variable by itself. So do you want to solve A or B, and do you want to solve for X or solve for a Y? And I think it's easiest to take A, X plus 2Y, that top equation, and solve for X. I can isolate X pretty quickly. All these other variables are going to take a minute for me to isolate. Because with this, I can just subtract 2Y. So X equals negative 2Y plus 4. Now my X is isolated. I've solved for a single variable. So what I'm going to do now is I'm going to take this equation and I'm going to substitute this in for X in the other equation. Don't take this, what you just solved, and plug it back into what you just solved. That's just back where you started. So now I'm going to go to my other equation, which was 3.5x plus 7y equals 14. But instead of the X, I'm going to replace it, substitution, with what I got in the other equation. So now I have 3.5. X is negative 2y plus 4 plus 7y equals 14. And now I only have one variable, y, and now I can solve for y. So distribute the negative 3.5, so we get negative 7y. 3.5 times 4, if you think that's like 2 7s, so that would be 14. Plus a 7y equals 14. Now notice that the y's here are going to cancel each other out, and I have 14 equals 14, meaning that that's a true statement. There was no variable. Your variables canceled out. You've seen stuff like this before. If it happens in a system, just know that the solution to the system is going to be infinitely many solutions. If you graphed it, it would look like that. So I don't have to go back to the next step. Your solution is just IMS. Now, let's take a look at one that's not IMS. So taking a look here, I have my top equation in the bottom, or A and B if you want to call them that. I could solve B for D. I could get D by itself, subtract 2C. That would be pretty fast. I could also solve this top one for C, and that's just preference. I'm going to solve the top one for C. I'd have more positive numbers, so C minus 5D equals 2. It's also just up at the top, so it's a little bit faster. So add 5D, so C equals 5D plus 2. I solved for a single variable, started there. Now remember, you're going to go to the other equation. So now I'm going to go to 2C plus D equals 4. And now I'm going to replace that C with 5D plus 2, what I found previously. Plus D equals 4. Notice I just replaced the one thing with what I got from before. Kind of like compositions a little bit, where you're replacing things and plugging things in. That's substitution. Now I'm going to distribute and solve. So I have 10D plus 4 plus that other D equals 4. Combine like terms and I get 11D plus 4 equals 4. Subtract 4. My variable is not canceling out here. I get 11D equals 0. You're allowed to have 0. From here, if you divided by 11, 0 divided by 11 is just 0. That's allowed. You can have that. You can't divide by 0, but you can have 0 in the numerator. That's fine. And now that you know that D is 0, now I can go back to my original one where I said C equals 5D plus 2. But now I know that D is 0, so I could say C equals 5 times 0 plus 2. 5 times 0 is 0. 0 plus 2 makes that 2. And then to write your solution, write it as an ordered pair. And I know you're like, it's not X and Y. That's okay. You're just going to use alpha order. So you could say C equals 2 and D equals 0, but you can also just write that as C comma D, which would be 2 comma 0. Always in alpha order for that. Now, let's take a look at a word problem. This says that a rectangular field is 12 feet longer than it is wide. So, in this rectangular field, it's 12 feet longer than it is wide, so L equals W plus 12. Now the perimeter is 76 feet. And if you think of a perimeter, that's all the way around. So you would have 2 lengths and 2 widths. So that would be 2L plus 2W equals our perimeter, which was 76. And then find the width. Now, I wouldn't want to solve this by graphing. And they already did the first step for you by solving one of them, isolating a variable. So this would be a good one to solve by substitution. So I'm going to start here. But instead of L, they already told me that L is just W plus 12. And then I leave everything else the same. So that 2L plus 2W equals 76. But instead of L, now I'm plugging in W plus 12. And then from here, I'm going to distribute. So 2W plus 24 plus 2W equals 76. Combine like terms, so you get 4W plus 24 equals 76. Subtract the 24. So 4W equals 52. And if you know how many cards are in a deck and how many suits there are, 52 divided by 4, there's 4 suits. There's 13 in each suit. And if you need to do long division, that's fine as well. So W is 13. Now, if this is a word problem, don't just say W is 13. What is W? What does that even mean? So anytime that you have a word problem and you have all of these words, you should answer with words. So I'm not going to say that W equals 15. I'm going to say that W is the width. And I'm going to clarify, it was of a field. So the width of the field is 13 and our units were feet. Now, before you ask, Ms. Bauer, are you going to count off if we don't do that? Yes. On AP test, they want context, and on this, we want context. Don't just say W equals 13. What is that? You can use whatever variables you want to use. Just make sure that you're clarifying what it is. Okay, now we're going to take a look at elimination. So we've done solving by graphing, we've done solving by substitution, and now we're going to take a look at solving by elimination. Okay, elimination is exactly what it sounds like. Substitution is taking things and replacing it. Elimination is simply eliminating things. So I'm not a science person, but I like to think of it as like protons and electrons. If you have like 5 protons, you need 5 electrons. You want things to kind of balance each other out. And like I said, I'm not a science person, so if that's wrong, don't come for me. But I'm going to take a look at this, and you need to decide, do you want to eliminate X? Do you want to eliminate Y? I tend to go with the smaller numbers. So right here I have 2X, and right here I have X. If I multiply this entire thing by a -2, it's going to make that X -2X, and then it's going to eliminate or cancel out. Now, that's a legal move. You can make them match. You can make sure that you have the right amount of each one, but you just have to multiply everything. So I'm going to keep the top one the same. 2x plus 6y equals 18. And then in the bottom one, I'm going to multiply by -2. So I have -2x minus 6y equals -18. And when I go to add those together, the x's should cancel out, and they do. 2x minus 2x cancels to 0. The 6y's cancel to 0. And then the 18's cancel to 0. So I get that 0 equals 0. Which means that, thinking back, if you were going to go and graph this, if you get 0 equals 0, that's a consistent dependent system. Everything lined up, everything matched up, everything canceled out. So your answer would be infinitely many solutions. And really the only way to check these infinitely many solution ones would be to graph it. Solve it by a different method. Solve it by substitution, solve it by graphing, and you should get the exact same thing. Okay? Now let's take a look at another one. If I'm solving by elimination, I want to eliminate the S or I want to eliminate the T. I want to eliminate one of the letters so then I could solve for the other one, okay? And from here, it doesn't really matter. Do you want to eliminate S? Do you want to eliminate T? Something that I'm noticing is that this is negative and this is positive. So those are kind of already on the right path to canceling each other out. My issue is that I don't have the right amount. I have 5 T's and I have 2 T's. So make the right amount. So I'm going to multiply this top one by a 2, and I'm going to multiply this bottom one by a 5. So in the top one, I get 8s minus 10t equals 6. And in the bottom one, I get 15s plus 10t equals -5. Remember that you're allowed to make however many you need to make for them to cancel out. You just have to distribute that to every single part. And then from here, I'm going to add them. Notice I put a little plus in parentheses to remind myself that I'm adding them together. Sometimes you might subtract them to cancel things out. So from here, 8s plus 15s would be 23s. My t's would cancel, that's what I wanted. Equals 6 minus 5 is 1. And then from here, I'm going to divide both sides by 23. So s equals 1 over 23. And I already have half of it. Now, some of you are already thinking, we can't have fractions. You can have fractions, and you will have fractions. And so you want to make sure that you know how to solve with fractions. Whenever you're multiplying fractions, if you have 7 times 1 over 23, that's just going to become 7 over 23. You just multiply them. But if I have 7 plus 1 over 23, now I need a common denominator of 23. So from here, I'm going to take this, plug it back into either equation for s, and then solve for t. So I'm going to now pick the one with the smaller numbers. I'm going to pick this one and I'm going to plug S in there because there's smaller numbers. That's the only reason that I'm picking that one. So I'm going to come over here and instead of 3S plus 2t equals -1, I now know that S is 1 over 23 plus 2t equals -1. And then I'm going to try to simplify this and solve it for t. And this is where we're going to pick back up in part 2. But take a minute. See if you can solve this. See if you can figure out what t is. We know what S is, but can you figure out what t is? And I'll tell you right now that t is going to be a negative fraction. See you in the next one.